Okay, so this is the assignment 4. We have to do the programming assignment for the vectors in string. Right? Have you done this? Oh no, you haven't done this yet. Okay. So we have to figure out how to use vector in strings. And the way it works is that number of rows, number of columns, the starting character, and the size cycle, meaning how many times it repeats itself. So let's say the size cycle is 3. So row, column, start, and then let's say it's 4. Okay? This is 3. Okay? No, it's 4. 1, 2, 3. I'll repeat 3 times. Okay, the cycle is how long it continues. So like from A, B, C, D, that's 4 cycles. Then 3 is the width. So each grid element is printed as a width square. So it is 3 by 3 by 3. Alright? So for the grid we will tackle it later. For now the main problem is how to create the board. Then we can print board the videos. So for the create board, what you guys need to imagine is the problem now is the mystery type. You're not so sure of. What the driver does, right, is that it calls the function using auto. And from auto we know that it can be any type. So it doesn't really bother about what type we give it. It's auto. So it can be any type you want. But there's one line that says here, a brief review of the containers containing a lecture should quickly lead you to deciding the object mystery type. So what we need is a container, right? And a container can be anything. It could be a vector, it could be an array, it could be a string, if you're that daring. It could be a class or structure. So since we haven't went through classes yet, you can either use structure or you can use vectors or strings. So what I did was I used structure. Let me just switch the screen. Okay, it's a bit small. Let me make it bigger. Okay. So what I did is I create a board of structures. Right? Save all this. Okay. Right. So the board of structures will have row, column, start, cycle size. I don't have the width here because the width is declared in the other function. So the argument, the width is declared here in the other function. So all you need is just to initialize the board. All you need is just this for data, for variable. So what command line parameters? Yeah, right. It's just one parameter. I mean, you guys read the thing. It gives you an input of like, it gives you this random input, 56A41 or 56A43. It could be anything. So you know that the input is fixed, so you don't really have to do much. You just need to work around that. So for how you manage to like use the input, like put it into your board, into your structure or whatever. That's one of the tricky part. So for me, what I did was just create a new board and then just return a reference to it, and just create a reference to it, because the print board demands a reference to the mystery type. Which since I'm using a structure, I need to return a reference to the structure. So I return the reference structure again. Okay, I like over she's or something. No, never mind. It's a bit shy. So yeah. So there's a lot of guards that you have to take care of. I can show you the guards in the PDF. Over here. Not over here, but over here. So So your function should print the same error as mine. If the standard on the standard error string, if it has too few common parameters. So let's say they never give us the total. No, we should expect 5, right? Minus the first one. So we should expect 5. 1, 2, 3, 4, 5. If they don't give us 5, if they don't give us 5 over here, they don't give us 5, we'll just output this, and then we return B. And we return B, right? We're returning an empty reference to an empty board. I mean, we're returning a reference to an empty board, right? So it's as good as doing nothing, because when you print, you're also printing an empty board, right? Makes sense? You don't need to return null pointer or anything, just return an empty board. So for this one, initialize board. So remember the 4 values that we have: row, column, start, and cycle size. So for this one, we are given a vector to a string. In order to access the elements in the vector, we can use the subscript array over here, or we can use the for range loop. But the one thing about the for range loop, right, is that you're not able to iterate through the whole thing. Like, let's say if you just want to store integers, it's fine, you can do that. But what if you want to store a character, like start is a character, then you have problems, right? Because you can't determine when in the loop will you start doing this. So to play safe, you can just do this. So this is just for readability. v.row, then you use the standard function string to integer, and this one you just store the first character, and then string to integer, and that's it, right? Now there's another exit function, exit condition here, right in the PDF. The second one, your function must silently exit if any of the integral parameters are less than or equal to 0. So what this means is that if any of these b row, b columns, or cycle size is 0, we just return the empty board, empty board. But it's not totally empty. It's just the row that's empty. I'll tell you why later. I will show you why later. Once the row empty, you are printing out empty output. And there's another function check. It's another guard that exit if the end cycle is not a valid ASCII. What this means, right, is that if you are printing, and then the last character, the first character must be ASCII code and not a control character like /n or backspace or delete, some weird characters are. And the control characters are not valid ASCII. So the way to check is that you make sure that the start plus the cycle is within the 0 and 127. That is the ASCII value that is in between the valid ASCIIs, right? And if it fails, you just return an empty board. And then if all this is passed, if they pass the test, then you give them back the initialized board that we initialized here. Make sense? Very clean code. Okay, now for this one. This one is a bit disgusting. It's just iteration. So the way it works, I think this one we will have to start drawing. Let me see if I can get my whiteboard up. Yes. Okay. So let's say we have, let me just take an example. A small example. This one. Zoom in a bit. Okay, you guys can see the thing clearly, right? Okay, so this is board with 5, 6, 8, 4, 3. So row is 5. Column equals to 6. Then we start with A. And we cycle 4 times. Right? So a plus 4 means we end the cycle at D. Makes sense, right? Okay, and now this is the width, right? 3. So what this means, right, is that you have 5 rows, let's say times 5, and you have 6 columns. So, oops, column times 6, right? But inside each row and column, inside here, we have 3 by 3 grid. Understand? So for each 5 row, each 6 grid, you have a grid here. They are 3 by 3. So it complicates things a bit. But I mean, if you just go through the iteration process properly, you just break it down into smaller and smaller for loops, you'll be able to figure out. So let's identify the largest loop first. Okay, let's imagine that if you want to print out something, right, we will the way we print is we print one line by one line, right? So we should start with rows. So rows should be our biggest what do you call it, for loop, our main for loop, right? Our line. Then afterwards we will print the individual characters inside. So you start with rows, number 1, then columns, number 2. Simple enough. Then once column reach the end, you just print /n, right? Remember /n, because of this, right, I face a lot of error. Do not use NL, do not use /r/n. Okay, use NL. So for row and column, so this is easily figured out. We've done this a lot of time already. Then the next step is to figure out the small grid inside. So for each row and column, there is a times 3 or times width and times width, right? But you're not going to times the row width. You're not going to just times it like that. It doesn't make sense, because if you want to do the cycle, you won't know which cycle you are at currently. So what you do, right, is you just insert a W in between. Make sense? So the for loop should be you run row first, then you run W, then look at column, then you do W, right? So this is how you do your for loops, like this. Then once you got that down, all you need to do is you need to adjust your cycle. This is simple. We've done this a lot of times. It's just character, just use a cast. Your cast start plus I, right? So I is our cycle. I will be our index for the cycle. So we have another loop here. Actually no, we don't need another. It's just W. But no, actually we do need another loop. I shouldn't erase it. It's very important. So what the problem is, right, is that how do you make sure that the cycle A, B, C, D, how do you make sure that this is kept? Right, you're just looking through everything. You're just plussing everything. How would we ensure that everything is that the cycle is printing in this correct direction? Meaning that if let's say the column is 6, right, we'll print 3 times of this, 3 times of this, 3 times of this, 3 times of this, right? Then we will print 1, 2, 3, right? Then we'll repeat 3 and then repeat 3, right? But because this is 3, then you also print downwards 3 times, right? A3, A3, something like this, right? How will you do this? If you will count 1, 2, 3, 4, you can do the first one, then you repeat 1, 2, okay, you can do this one. But then when you count again, this will become 3, but we are expecting a 1, right? So you need to do some voodoo magic to figure out how to. Oh nice, top post got extension. Okay, then my off topic. Okay, so some voodoo magic. The voodoo magic is done using modulus. Right? You guys remember modulus? So what this is doing, right? Remember modulus, what modulus does is that it takes a value. Let's say our cycle is 4. Then you percent it. This is our cycle, right? Percent it with rho or percent it with W. So if rho is 1, you'll get 1, right? If rho is 2, you'll get 2. If rho is 3, you'll get 3. If rho is 4, you'll get will we get 4? Oh wait, you should actually start from 0. Right, then rho is 4, then you get 0. Okay, forget, you always count starting from 0. So you ensure that this is the loop that is kept. Same with W, you work it out, it will work the same way. And then, so for what I did in the code is that I initialized the I over here to be rho percent port size. So what the cycle actually means, right? You don't have to think too hard about it. But if you look at the PDF not sure. PDF, come on. You look at the PDF, right? It's actually a bit tricky, and you can blame Pasana for that. Actually, I don't know who sets the paper, but I'm just gonna blame Pasana. What's actually happening, right? What's actually happening, right? Is that you're not counting 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 1, 2, 3. No, you're counting 0, 1, 2, 3, 1, 2, like that, correct? But your cycle is also going this way, 0, 1, 2, 3. Do you realize that? Your B is here, then your C goes here, then your D goes here, then your A goes here. You see? That's the tricky thing. You're not counting in a continuous fashion like this. No, you're counting one way, and then you're counting another way. So this part also tripped me out a bit, but no matter. So what you do is just to figure this one out. Oops. To figure this arrow out, it's just W percent cycle, and here is R percent cycle. Oops, I'm spelling it wrong, but it makes sense, right? First, A is 1R, B is 1R, C is 1R, D is 1R, A is 1R, right? Okay, for this one, oh, it's not W, it's C. C is 1R, another C, another R, another R, another R, another R, right? So it's just C percent cycle. Make sense? Legit, right? The math check out. So yeah. So just column I equals to rho percent. Then just indent as a column indent, your I indents. And your I only change once this W is done. Once this W print out all the 3 or 4 or 5. This is to make sure that the I stays within, the column stays within the board cycle size. And that's it. Then once you're done finishing with the column, you print a new line. Right? You do this. You print a new line. Then you go to the next row. You go to the next WX. You do the same thing again. You don't have to worry about much because your row here transfer to your I here, and your I here you're always checking it using modulus, and that's it. Oh, and one more thing about the width. Right, you're given this string constant width. There is a check you have to do also. You can use try catch, which is what I did, and this is to make sure that the width, right, they give you isn't garbage. If you're not able to convert it to to an integer, then you just return. Okay, but if you are able to convert it to an integer, you continue, and w less than 0, you return, because you cannot accept values that are below 0. They are useless and they can't do anything. Right, and that's it. Easy as that. I'll upload this later, and I'll just stop this recording now, then we move on to the next one.